Make it bigger first. Okay, 9-6, graphs of other trig functions. Let's review graph of sine and cosine first before we do anything else. Okay, to enter quietly. Shh. Here we go, sine and cosine. Let's graph what sine looks like, and let's graph what cosine looks like. Sine, cosine. Just so you have them as review on the top of this paper, because we're going to talk about the differences between sine, cosine, and tangent. So, sine starts here, goes up, comes down, goes back up again. And it goes up as high as how far? 1 and -1. And 1 full period is 2 pi. The period of a sine is 2 pi. Keep that in mind, right? The period of sine is 2 pi. Right here, it's at this middle part at pi, right? Okay, 0, etc. Cosine starts up, goes down, comes back up again. But what is this mark right here? What's that point right there where he stops again? 2 pi again, right? Okay, here in the middle is pi, starts at 0. He goes as high as 1 and as low as -1. It's same as sine. The period of cosine is 2 pi, right? It makes 1 full cycle in the amount of 2 pi, yes? Good? All right, now, how is that different from tangent? Well, for one thing, tangent kind of looks like the x cubed function. X cubed does one of these. It looks like a little s, kind of, but up and down, you know? That goes on forever. He's kind of a little squiggly. That's what x cubed looks like. Tangent looks the same, okay? And tangent is starts at 0, 0, but then he goes on either side of the 0, 0 mark in that x cubed kind of way. And he has like vertical lines that kind of enclose him. What are those vertical lines called, by the way?
Asymptotes.
Vertical asymptotes. ASYMPTOTES. That's what an asymptote is. Those are vertical asymptotes. They basically are the lines that bind, or bound, I guess, tangent, so that he does not go outside of those lines. So he has one section, then he has another section, then he has another section, and he is bound by those vertical asymptotes. Now, how wide is tangent? If you look at this asymptote over here, this is -pi/2. Over here is +pi/2, right? That's half of a pi on either side of 0. So what is his full period? Just pi, right? Just pi. So the period of tangent is pi. That is different from sine and cosine. What's the period of sine and cosine?
Anything.
2 pi, and that's not anything. It's 2 pi, right? You can change it to be anything. But the period of just normal sine and cosine is 2 pi. That's a problem, okay? Now, tangent does not go like in a cycle, like wave up and down. He will never touch these dotted lines here, so he kind of has a break in his graph, and his domain is not infinite, right? Like sine and cosine. Sine and cosine go forever and ever, left and right. So does tangent, but you will not have places where tangent is at these 2 points, right? Because he has a vertical asymptote there, okay? All right, so now, blah, blah, blah. Let's go down here. Y equals tangent of pi/2. Okay? So tangent. Let's talk one more thing about tangent. Okay? One more thing about tangent. Tangent really doesn't have an amplitude. Do you remember last year talking about that? Tangent really doesn't have an amplitude. Okay? But we're going to say just for right now that the amplitude of tangent is 1 because the number in front of tangent is 1. What that means is that since his midline here is at 0 and since here is at pi/2 where he stops, the mid part right here, what's the halfway between 0 and pi/2? Pi/4. At pi/4, he will be up to 1, right? He will be up to 1. And at -pi/4, he will be down at -1. Does that make sense? So if I change the number that's in front of tangent, like this guy right here, this 3, what does that do to tangent? It makes him taller and skinnier, right? It like flattens him out, right? So instead of it being here at 1, he's going to be all the way up here at 3, and he's going to do this, right? He's going to be a lot taller and skinnier. Does that make sense? That's what that 3 does, okay? So tangent really doesn't have an amplitude, but it helps you to think of it that way. That's okay. Do that, okay? So like the amplitude of tangent normally is 1, but when you change that number, he makes him taller and skinnier. Okay, so let's talk about this guy. Tangent of pi/2. So this is like the same thing as tangent of 1/2 x, yeah? Tangent of 1/2 x. And this is, which one is this? A, B, C, or D? That's B, right? A is the number in front, B is this guy. There's no C and D involved in there, so that is B, okay? Now, to find a period, we usually use B, right? And it's usually 2 pi over B, except tangent's period is not 2 pi. It's just pi, right? So we do pi over B for tangent. So that would be pi over 1/2. And then we keep flip. So we keep the pi, multiply instead of divide, and do it by 2 over 1. So what is tangent's period if it's tangent of x over 2? The period of tangent is 2 pi. It is changed. Period is 2 pi. So what he will look like instead is this. Okay? If his period's 2 pi, he's still going to do this, and he's still going to do this, except my vertical asymptote here and my vertical asymptote here will be at different markings. Normally it's at pi over 2 and negative pi over 2, but if he's 2 pi in the total length, how far will he be on either side? Pi and negative pi, right? That gives me a distance of 2 pi. Does that make sense? And then he goes over again, right? He keeps going forever, right, in both directions. Okay, are we good? Yes, good there? Okay, now, in this one, we have a couple things going on. We have the 3 for 1, so that changes kind of the amplitude. Tangent really doesn't have an amplitude, but it will change it to like 3 if we call it amplitude. And then the period. The period, what do we do to find the period of tangent? Pi over B, and B is, in this case, 2. So pi over 2, and there's no way to simplify that. It's just pi over 2, right? And then the negative will make him flip to the other direction, so he'll go downhill from left to right. Okay, so let's map this out here. We have not horizontally shifted him at all, so I'm going to be lazy, and I'm going to, well, no, I'm not. I'm not going to be lazy. Pi over 2 is how wide he is. He starts here, and he goes out. Where are my vertical asymptotes going to be at? Nope, pi over 2 is the whole length of the whole thing. Pi over 4, right? It's like half on this side, pi over 4, and half on this side, negative pi over 4, yeah? Pi over 4, negative pi over 4, right? And then he's going to split there, okay? Now, to do the amplitude, even though tangent doesn't really have an amplitude, to do the amplitude, we look at halfway between 0 and pi over 4. What's halfway between here? Pi over 8 would be there, right? Pi over 8 and at negative pi over 8, right? And at pi over 8, negative pi over 8, he will be up to 3, and he will be down to negative 3, right? Okay? So I'm going to go up to 3 over here and down to negative 3 over here, except he's flipped, so he needs to be up to here and down to here, right? And so he's going to look like this. Yikes. There we go, there we go, there we go. Yikes. So he's a little bit taller and skinnier. Taller and skinnier. And he's negative and all that good stuff. Make sense? Yes, and then another section will repeat, another section will repeat, and he goes left and right forever and ever and ever, right? Good? Makes sense? Yes? Okay. All right, let me look at the back side of this. Cotangent. Okay, let's graph what cotangent looks like. The graph of cotangent. Cotangent is like the reciprocal of tangent, right? Okay, here's what cotangent looks like. Same as tangent, except your period's still pi, except instead of him overlapping 0, one of the vertical asymptotes is the x or is the y-axis. So there's a vertical asymptote, and a vertical asymptote is over here. And his period is pi. Yeah? And he goes downhill. Does he go downhill? I gotta think. Does he go downhill? For some reason I can't think of this. He goes downhill? Okay. Cosine does? Or cotangent does? Yeah. So he goes downhill. So he is going to cross here. Where does he cross there again? Where is his vertical asymptote going to be over at the right? Pi, right? Instead of it splitting and being pi over 2 and negative pi over 2, it's just going to be 0 and pi. Because it's still pi units. I'm going to put a period here. Period is still pi. Okay? But instead of him going this way and crossing halfway between, he's going to go downhill. Where is that crossing point? Pi over 2, right? Halfway between 0 and pi is pi over 2. Does that make sense? Maybe? Maybe? period is still pi, so when you're changing period, it's pi divided by b instead of 2 pi divided by b, just like tangent is. So that's what he will look like normally. Good. I feel like I'm going through this really super fast, am I? Is Cade following along? Because if Cade gets it, everybody else has got to, right?
So cotangent is backwards.
Cotangent is backwards
Okay.
and shifted.
Right, Andrew?
Cotangent is backward and shifted. Yep. So instead of him overlapping 0, like negative pi over 2, positive pi over 2, he's shifted over and he goes downhill. Yep, that's the way he always goes. That's what normal cotangent looks like. This is normal cotangent until we move him. Okay? Ready to move him? Let's move him. Move him on the back side. 2 cotangent pi over 3. This guy is your A and this guy is your B. He is like 1/3 x, so B is 1/3. Right? B is 1/3. Okay, so let's talk about this. The A is changing the amplitude, if that exists, of cosine or cotangent. I don't know what we should call it instead of amplitude. The height? I don't know.
I asked you that one.
What?
Yeah.
I don't know. I'll have to figure it out. So amplitude is 2, cotangent. This will affect the period. Period. To find period, we don't do 2 pi divided by b. We do just pi over b. Pi over b. And pi over
Yeah, I can talk.
Pam? Sure. I don't know. Pi over 1/3.
Yes, Pam.
Where's the Pam?
I don't know. Where's the Pam? I don't know.
Pam.
Pi divided by 1/3. You multiply by the reciprocal, so 3 over 1. So my new period is 3 pi. New period's 3 pi. Okay, so let's graph this guy right here. Okay, we haven't shifted him left and right at all. So we're still going to have a vertical asymptote there, and we're going to have a vertical asymptote over here, but where is he at now? Where's his vertical asymptote at? 3 pi, because now he's 3 pi long, right? Okay, so what's halfway in between where he should cross? What's halfway between?
1.55.
3 over 2.
3 over 2, right? You divide it in half, huh? 3 pi over 2. 3 pi over 2. Okay. 3 pi over 2. Okay? Now,
The amplitude.
now, what is halfway here? That's kind of hard to think about.
It's.
3 pi over 4?
Yep.
3 pi over 4 and whatever that is on the other side. I don't know. 3 pi over 4. 9 pi over 4. I don't know. It's 9 pi over 4. I know. I'm sure it is.
Are you sure?
Yeah, I'm sure. Why not? Why not? 9 pi over 4. Because 3 pi over 4, you just take this guy and divide by 2, right? But then you add those two together to get this guy, right?
I just want to get
3 pi over 4 and 3 pi over 2 added together is 9 pi over 2. Whatever. It's not terribly important. Amplitude.
Pam plus 2.
Pamplitude. Okay. Whatever. Pamplitude is 2 and negative 2. Okay, and he's going downhill. So here he should be at 2. Here should be at negative 2. And he's a lot taller and skinnier than what he normally is. That's darn good looking right there. That's what he looks like. Yes? He's almost as straight as that. Yeah? Happy with that?
It's almost like a straight up down.
All right, now graphs of reciprocal
Wait, why is
functions.
mine not like a straight up and down line?
I don't know.
It's not a straight up.
It's not supposed to be. It's not supposed to be a straight up down line. Okay, graphs of reciprocal functions. So cosecant goes with sine, right? And secant goes with cosine. Cosecant and sine, secant and cosine, okay? Now, to graph cosecant, you always graph sine first, right? Sine looks like this. Up and then down and then up and then down and then down and then up and then blah, blah, blah. That's what sine looks like. So all you do for cosecant
Up,
is you put your vertical asymptotes in and you make your hills and valleys off of the original. So there are vertical asymptotes in there. Watch this. There are vertical asymptotes in there. And then you draw, they're kind of like little parabolas off of your hills and valleys. Make sense? That's what cosecant is. Okay? He has vertical asymptotes in there, and he's like the hills and valleys, the parabolas off the hills and valleys of sine, right?
You like it.
We like it. So, the same rules apply. What is the period for cosecant? What's the period going to be for cosecant? What's the period for sine? 2 pi. So the period for cosecant is 2 pi. Right there. Okay? What's the period for secant going to be?
2 pi.
2 pi, because the period for cosine is 2 pi, right? Okay, so when you do your period, it's 2 pi over b instead of pi over b, which is only tangent and cotangent. All right, so this guy, cosecant, or cosine, excuse me, cosine looks like this guy. And your vertical asymptotes are here, and here, and here, right? And then you just do your parabolas and your hills and valleys off of those. So, anytime you're graphing secant or cosecant, graph sine and cosine first, probably pretty lightly, and then just do your hills and valleys off of those. That's what cosecant looks like, okay? All right, let's do an example, this one down below, and then we'll wait and talk about damped trig functions later.
Yeah.
Damped trig functions, not damned trig functions, although you kind of feel that way too, but damped trig functions, we'll talk about those later, okay? So when sketching the graph of 2 cosecant of blah, 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 you're going to sketch the graph of 2 sine, okay? So let's fill this out. Amplitude, period, horizontal shift, vertical shift. Amplitude, period, horizontal shift, vertical shift. We're going to graph that sine function first. What's the amplitude? 2. The next easiest one to do is vertical shift. How are we vertical shifting it? Nothing, because that would be like plus whatever's over here. There's nothing there, so there's no vertical shift here. Okay? The period. For cosecant and for sine, the period is 2 pi. So we do 2 pi over b. And what's the b value here? 1. So 2 pi over 1 is just 2 pi. So it stays the same. Stays the same. Okay? Now, horizontal shift we do negative c over b.
Which is 1.
Okay? So c would be negative pi over 2
Uh-oh.
over b is 1. So what's negative pi over 2 divided by 1? Negative pi over 2. Okay, so let's graph him here. La la la. Okay. All right. Okay, all right. Here we go. We have not shifted him up and down at all. No vertical shift. But let's go ahead and let's go back here at negative pi over 2. Negative pi over 2. That would mean over here would be like positive pi over 2. Right? And this guy would be, what's the next interval after pi over 2? Pi. And then 3 pi over 2. And then 2 pi.
What? Wait,
No.
wait. Yeah,
Right?
pi over
If we're going by pi over
7
2,
pi over 2.
then 7 pi over 2. Yeah, if we wanted to just, well, no, not 7 pi over 2. This would be 5 pi over 2.
Right.
I was close.
This would be 5 pi over 2, blah, 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 etc., right? Okay. Okay, so we could keep going on forever. Now, we're starting at pi over 2. If you like to make the dotted lines, you can go right ahead and do that, right? He's going to start there, and his period is 2 pi. So where is he going to end up if he starts there? Normally it would go, normally it would go from 0 to 2 pi, but I'm shifting him this way, so it's going to go here, right? 3 pi over 2 is where he's going to end. Do you see that? Yeah? So there's where he's going to end. If it helps you to make those vertical lines, they're not vertical asymptotes. Don't get that confused. I'm just thinking my vertical lines of where my things start and end. Yeah? Yeah. Okay? All right, so sine. Sine is going to bounce around in between those two.
Jump around.
Amplitude is 2. Okay. Negative 2. Okay, he's starting here. We haven't flipped him, right? So we're starting here. He should start here, end here. In the middle, he should be back to 0, right? So here he should be up to 2. Here he should be down to negative 2. Do you see my dots that I'm going to connect here? La, 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 la. There he is. Okay, but that's not the graph of cosecant. That's only the graph of sine. So, how do I do cosecant then? Do the parabolas. Right here, there he is. And there's another one. And I have my vertical asymptotes, oh looky there, in the right spot. So they were vertical asymptotes all along. And I need one more vertical asymptote to be there. He is right here in the middle. Right there. Exactly at pi over 2. You're right.
Woo!
Woo! How does that sound? Good? Okay. You will have one question on damped trig functions at the very, very end, I think. So you go ahead and skip that one. We'll save that for on Monday, maybe. Or not Monday, tomorrow. I wish today was Friday. That would be really nice. We'll say that for tomorrow, but do the rest of them. 12 through, I don't know what it is, 12 through 20. ways. Do those on the board. Okay, there you go.